Good morning. Today we are going to learn about real numbers. In this one, we will discuss about the revisiting irrational numbers. In the ninth class, we have studied about the what are the irrational numbers. The irrational numbers are what? Like example, root 2, root 3, root 5. These are the examples for irrational numbers. But actually, we have not proved how they are irrational. We just know about the what are irrational numbers, but we have not proved how they can be proved as irrationals. Now in this chapter real numbers we are going to learn how it will be proved as irrational numbers. Now before going to that we will discuss a small theorem regarding this because this theorem helps us to how to prove that these are irrationals, helps us indirectly. Now see that what is this theorem? Theorem is 1.3. Now in the theorem it is telling that if p be a prime number then p divides a square. Then p divides a where a is a positive integer. If p be a prime number, then if p divides a square, then p divides a, where a is a positive integer. So in this theorem, it is telling about there are two numbers, a and b, both are positive numbers, where a is any positive integer, b is a prime number. A is a just positive integer, b is a prime number. So one is prime number, other one is a not compulsory prime number. So how they are proved? So let us take that. Let us take a be the any positive integer, let a be the any positive integer. Now because it is a positive integer, so that we can express it as a product of prime numbers. So a equal to, we can write as p1 into p2 into p3 and so on. It is expressed as product of prime numbers. Since we know that from the fundamental theorem of arithmetic, we can express it as product of prime numbers. Now, if you take a square, how do you get? P1, P2, P3 and so on, Pn whole square. That is a square equal to P1 into P2 into P3 and so on, Pn into P1 into P2 into P3 and so on, Pn. So, what is given? Given P be the any prime number. P be the any prime number. So it given that here in the statement it is given that p divides a square. If p divides a square, then p divides a. If p divides a square, that means your given statement is what? Here given p divides a square. This is given. So how to prove this? If p already given p divides a square. So p divides a square means p must be divide the one of the factors of the a. P must be divided the one of the factors of a. Then only p can divide a. Therefore, p divides one of the factors of a. P divides a square means p divides the one of the factors of a. Therefore, p must be the one of the factor of a. It implies factor of or a factor of p1 comma p2 comma p3 and so on pn. P must be the one of the factor of p1 comma p2 comma p3 and so on pn. So here p1 p2 p3 is nothing but what? It is nothing, the product is nothing but a. So p is a factor of A. So P is factor of A means P. So P is a factor of A. So P must be the factor of A. Therefore, P is factor of A means P can divide A exactly. So P divides A. P divides A. This is the theorem telling about. Finally, we can say that if P divides A square, then P also divides A. Now this theorem helps us to solve the problem. How to prove the an irrational number can be proved. For example, see that root 3 is an irrational number. We know that root 3 is an irrational number. Then how can this be proved? Actually, this can be proved by the method of proof by contradiction method. Proof by the contradiction method. So how it is proved? We have to see that this can be proved by proof by contradiction method. Proof by contradiction method. Proof by contradiction method. So this is indirectly, we will prove it indirectly. So by proving indirectly, when we proving the root is irrational, somewhere we get some contradiction. Using that contradiction, we will understand that we will come to a conclusion. So that we will prove in this method. So how it is proved? Let us see that. Let us actually we know the root is irrational, but how it is proved? So how it is proved? See that. Let us assume that root 2 is a rational number. So we already know that if a rational number can be expressed as a p by q form, so that I can write root 2 equal to p by q, where p and q are integers and q is not equal to 0. P and q are integers, q is not equal to 0. So that suppose p and q have a common factor, common factor other than 1. Suppose p and q have a common factor other than 1. Then what happens? So if suppose you see that 2 by 4 is there. So 2 and 4 has common factor 2, because 1 can divide both, 2 can divide both. So I can divide with maximum number, 2 ones are 2 2s are. So I will do it. So so that I am writing the standard form of the rational number. It is standard form rational number, but it is not standard form, because it is still we can simplify this like this. Here also p by q is a rational number, but it is not in the standard form because it has a common factor other than 1. Then if you cancel with common factor, then if we cancel with, suppose p1 have a common factor other than 1, we have to cancel p by q with the common factor. We have to cancel with a common factor to get root 2 equal to a by b. We have to cancel with a common factor to get root where a and b are co-primes. What are co-primes? Co-primes are nothing but the two numbers having no common factor other than 1. Such numbers are known as co-primes. Here 2 and b have the simplest form. They cannot be cancelled again and again since they are already in the simplest form. Now see that where a and b are co-primes. Now let us take root 2 into b. Root 2b equal to a. Squaring on both sides. So root 2b equal to root 2b whole square equal to a whole square. Now 2b square equal to a square. Suppose this equation 1. Now b square equal to a square by 2. So from this we can understand that 2 divides a square. So that we can get b square. 2 divides a square means 2 also can divide a, because just now we discussed about the theorem 1 point is such that if p is a prime number, a is any number, then p divides a square means p also divides a. Using the same concept, 2 divides a square means 2 also divides a, since 2 is a prime number. Therefore here 2 divides a square, then 2 also divides a. Let a by 2 equal to c, because 2 divides a, then result is c, where c is some quotient, where c is some quotient, where c is some quotient. It implies a equal to, we can get 2c, 2 into c, 2c equal to c. So substitute a equal to c in equation number 1. Then what you can get? Actual equation 1 is what? 2b square equal to a square. 2b square equal to, in place of I can replace 2c. So 2c whole square. So 2b square equal to, I can write 4c square. I can write 4c square. So cancel 2 1s are 2 2s are. So b square equal to 2c square. Otherwise I can write 2c square equal to b square. 2c square equal to b square. Now I can write c square equal to b square by 2. Again we can observe here 2 divides b square. So 2 also divides b. Here 2 divides b square, then 2 divides b. 2 divides b square, 2 then 2 divides b. So from the above statements, here we can get 2 divides b, and just now we have got the 2 divides a. So from the both statements, from the above statements, from the above statements, 2 is a common factor of 2 is a common factor of both a and b. So we got 2 is a common factor a and b, but we know that a and b are co-primes. But we know that a and b are co-primes. But we have got 2 is a common factor a and b. So this is contradiction. Actually we know that a and b are co-primes, but we have got 2 is a common factor a and b. This is contradiction. This is contradiction. Why? Because in the beginning we have assumed that a and b are co-primes, but in the process of solving problem we got 2 is a common factor of 1 and b. This contradiction is erased. This is contradiction. So this contradiction. Why this contradiction has happened? This contradiction has arisen because of our assumption is wrong. Why this has happened means because of our assumption is wrong. So we conclude that 2 is a irrational. Why? Because a number can be either rational or irrational. We know that. So that in the beginning we have assumed it is rational. So we have understood that it is not rational. So if it is not rational, so we can indirectly it should be a irrational. So this is the proof of root 2 showing as irrational. This method we applied is known as proof by contradiction method.